Hi, so I'm starting with my series on parametric equations. So I'm also doing a question that was in the examinations of 2021. And you have got the two parametric equations in terms of t. And we are told that the curve meets the x-axis at 2 points. When something meets the x-axis, then y will equal to 0. Okay, so let us just then bring in that one here. I have got t and f1 plus t. Let me find those two values when y is equal to to 0. Okay, so let's see what these equations will be. And then, I mean, these values would be, this implies that t equals to 0, or t plus 1 is equal to 0 and t is equal to -1. Right, so why are these points important? Well, I'm going to use these points when I find the derivative, because you are given another piece of information. It says find the equation of the tangent, and in order for me to find the equation of the tangent, you will have to say, okay, what is dy dx? And once I have dy dx, and I'm going to punch in these 2 points in there, all right, to find obviously my gradient of the equation for the gradient of the tangent. Okay, another thing worth doing, once we have the corresponding values of t, so let's just go back into our x equation, because we'll be needing x values. So x would be 2, and then we are going to substitute when, so in this first case, the other one is x equals to 2. We're going to substitute here. The first instance, I'm going to substitute when t equals to 0. Okay, x happens to be 0. Here, when t equals to -1, -1 here, -1 here, well, x is 20. So I have got 2 points now that I will be considering, and the points are, I have the point 0, 0, and I have another point which is 20, 0. Why are these points important? Well, of course, I'm going to use these points when I am finding the equation, because you are told that you need to find the equation. So for you to find the equation, this is normally the formula that we will be using. Okay, another thing then obviously that we know is, we know that this one here is x sub 1 and that is y sub 1. So that's x sub 1 and that is y sub 1. So what's important for us is to find m. Once we have m, we can find the two equations that they are looking for, because it says find the equation of a tangent to the curve at these points. So at these points, plural, it implies we're going to have two equations. Okay, right, so find dy dx. So how do we then find dy dx? Right, in order for us to find dy dx, let me just write down what is x equal to again. Now x is equal to 2, and that is t squared minus 18t. Okay, just remember it from here. Of course, just put t, that is what what the x is, and y, and let's just write y also at the same place, okay, in the same line. Y is equal to t in bracket t minus 1, or was it t plus 1? Let's make sure what the value of y was. Now, in fact, I just rewrote it, but it doesn't really matter. Let's just multiply these out. So this t squared plus t. Now, we can do dx dt over here. Now, dx dt, that is 4t minus 18. And here we can do dy dt, that is going to be 2t on its own. Okay, so plus what? Plus 1. Very important that we write that one down. And now let me just also take note of something, because we're going to use the chain rule. So if this dx dt is equal to that, then dt dx will be, the opposite of that, which is 1 all over 4t. Oopsie, that 4 looks really not like a 4, but it's a 4t minus 18. Let's just play around and correct that 4. Okay. Now, what is, therefore, we can actually now say, therefore, dy dx is going to be obviously dy dt, which is the 2t t plus 1, and then we want to multiply that by 1 over 4t minus 18. Right, numerator times numerator, so dy dx is going to be nothing but dy dx is nothing but 2t plus 1 all over, my goodness, all over 4t minus 18. Right, so we need to be able to find our gradient. Now, let me just include a page, okay, because I think I have went overboard. So let's just insert a page, or append a page rather, so that we can have space to work on. Right, let's start over, okay, handwriting is not desirable. When t equals to 0, dy dx is equal to 2 times 0 plus 1 over 4 times 0 minus 18. Well, of course, this is just going to give you right. So therefore, we have the gradient. We have the gradient m equals negative 1 over 18, and we have the point 0, 0. So we are going to use this formula here, y minus y sub 1 equals to m, then you have x minus x sub 1 to find that equation. Okay, we can quickly do that. So it's going to be y minus x is y is 0 is equal to negative 1 over 18. X is nothing but also 0. So eventually this is just going to be y equals negative 1 over 18x. And this is surely the tangent of one of them. Okay, so let's find the other one. We will say when t is negative 1, then dy dx, what was dy dx again? Okay, we can just copy from here because it's 2t plus 1 minus 4t, so it's 2 and negative 1 plus 1, so that is 2 in brackets negative 1 plus 1 over 4 times negative 1. Now this is minus 18. Just make sure that we are on the right path. Minus 18, good. So let's find what the gradient is here. Then the gradient here is going to be negative 2 plus 1. That's negative 1 over, okay, negative 4 minus 18. That's negative 22, which is 1 over 22. What was our point? Well, if you remember well, our point was the point 20, 0. Okay. Remember, I did these points previously, so just going to show you, very important that you do have those points, okay, as I was mentioning them over here. These were my points, and I'm putting them back here because I'm going to find the gradient. I mean the equation. I did calculate the gradient. So if I have the gradient, then my equation y minus y sub 1 is equal to that gradient m x minus x sub 1. So you take one y value, of course y is 0 through and through, the gradient is 122's x minus 20. Okay, so this is already the answer to this, but let us just clean this up. Write it in y equals mx plus c form. Okay, multiplying out, of course distributing this with that and that with that, was minus 20 over 22. Okay, we can clean it up a bit. So it's going to be y equals to 1/22 of x minus 10/11. Now, totally up to you. Again, as I said, any one of the other previous, you already have the solution. So those are the two tangents to the respective equation that we're supposed to do when you're dealing with this question on parametric equation.